Okay, this video is for Algebra 2, Section 8.4. We're going to be doing some graphing today in this video, and we will only get through example 1 and example 2 probably, and then we will stop because it does take a little bit of time to graph some of these, but they're kind of fun. So we're really looking at the distributions of data. There's kind of three different ways that we're going to talk about at least to distribute data, and sometimes you'll have where there's not a lot of data down here on the end, like on the lower parts, and then most of your data is going to be toward the higher end. So this is kind of an example of this would be like grades in the class. So hopefully your grades, you have very few grades that are down here in the 60s, like 60%, and you have a lot of grades that are up here in the 90s and the 100s, okay? So the height of each one of these bars is the frequency, so like how many there are. So maybe you have a lot of homework grades or a lot of test grades that are up here, and then very few or not as many in those lower grades, okay? A symmetric distribution kind of has like the middle right here has the most, and then it kind of tapers off on either side. And so, I don't know, most of what we're going to start talking about is going to be a symmetric distribution. This is kind of that bell-shaped curve that we're going to start talking about. A positive distribution is going to be the opposite of negative distribution, where most of your stuff is down below here, or most everything is down here in the 60%, up here in the 100%. You're not going to have quite as many. So if you refer to it as grades that way, you can look at this. So this is probably like a poor student because they have a lot of grades down here that are in the 60s and not as many in the 100%. So if you look at it that way, this would be not positive, but it still represents a positively skewed distribution. This would be good if you're talking about death rates, okay? So if you think about it that way, if I want as many, low percentage deaths, I guess, and not as many high percentage deaths, I guess, is a way that you could think about it. But negatively skewed, positively skewed, and then symmetric in the middle. Things to note about this is that for symmetric distribution, your mean or your average is going to be the same as your median, or about the same, which is your middle number. Okay, so if you're looking at a data set, your average number and your middle number will be about the same right here in the middle. Okay, when you're looking at a negatively skewed number distribution, the average or your mean is going to be lower, AVG, is going to be lower than your middle number. Okay, the middle is going to be here, but your average is going to be a little bit lower than that. And then it's going to be the opposite of that for positively skewed. So your average here will be higher than your middle number here. Okay, and we'll kind of see an example of that, moving on. But that's just kind of the way that this data is going to work. Okay. Positively skewed, negatively skewed, and symmetric distribution. Okay, so in example 1, they want us to create a histogram, which is exactly what these are up here with the bars, minus the little curve that they've slapped over top of it. But the histogram is just a bar graph where all the bars are going to be touching each other, okay? And they give us a bunch of data here. I think there's 32 numbers here, so 32 numbers total. And they want us to create a histogram with that stuff. So they want us to make bars. And what we're going to do is we're going to lump off some price ranges. We need to first put them in order, but then we're going to categorize them into like sections. So maybe we go by hundreds of dollars. I think our lowest is like $390. So maybe we go 300s and 400s and 500s and 600s and 700s and figure out how many are in each range. And then that will tell us the tallness or the height of our bars here, okay? So what I've done to help me out, because I can't sit here and cross off and put them in the correct order, I went ahead and on an Excel spreadsheet, I took this data and I typed it in here in this first column. This stuff is going to be stuff that we're going to use on the backside. But I've typed them into this first column, and what I can do is I can select that column by clicking here. This is on an Excel spreadsheet, but it's also kind of the same for Google Sheets. You can select that top column, and then what I can do is I can hit this button here, and I want it to go in ascending order, which is going to go small to large, and it's going to go ahead and just put those in order for me. And then I can just rewrite those down. So that makes it really super nice that I can do that. Okay, so I'm going to copy those numbers down here, and I might use a pencil to do that. The tip of this marker is just too fuzzy and you can't see it very well. So start with 374. Second number is 386. This is going to get kind of tedious writing these down. 389, 390. You can probably write these faster than I can. 410, 420, 425, and 440 is the end of the first column, okay, or the first row. Then we start with 463. Then we go to 470 and 472, 490, 502, 508, and 512. I really hope I'm not skipping any numbers here. 523, there we go. All right, 538, we start the next row. 552, 572, 605, 613, 618, oh my goodness, 621, and 659. Last row, 671, 706, 723, 734, 752, 811, and 847, and last one is 915. Oh my goodness. Okay. All right. So this is my data set, putting these numbers from here in order into that data set. That kind of made it helpful for me. Okay. So describe the shape of the distribution. What I'm going to do is I'm going to kind of make a list of how many are in each category, and we have to decide what our categories are going to be. So are we going to go like 300 to 350 as a category, 350 to 400? I think that since we have numbers that are in the 300s and our last numbers that are in the 900s, maybe it would just be beneficial to go like 300s, 400s, 500s, 600s, 700s, 800s, and 900s. Okay, and then figure out how many are in each category. Okay, that's probably the best route to go. Otherwise, if we go more frequent than that, we're going to end up with a ton more categories. That's already 7 categories right there. Okay, so how many numbers do we have in the 300s? We have 1, 2, 3, 4. Okay, in the 400s, 1, 2, 3, 4, 5, 6, 7, 8. Okay, in the 500s, we have 1, 2, 3, 4, 5, 6, 7. 600s, there are 1, 2, 3, 4, 5, 6. 700s is 1, 2, 3, 4. 800s, there's 2, and 900s, there's 1. Okay, I am going to check to make sure I got all of those by adding them up. Okay, and they should add up to be 32, because there's 32 numbers. So plus 7, plus 6, plus 4, plus 2, plus 1. 32, we got them all. Okay, so, and then I'm just going to make my bar graph here. Okay, so the tallest bar will need to be 8 units tall. So I'm going to go ahead and mark him up here at 8. Here is going to be 4, that's halfway in between. Okay, the zeros at the bottom here. This guy would then be 2, this would be 6. And just splitting. This would be 1, 3, 5, and 7 is how I'm going to do that. Okay? All right. And then you might have seen this before. This is like that broken symbol. Okay? And then this means I'm going to start here and I'm going to make this chunk my 300s. I'm going to make this chunk my 400s, 500s. This gets really tedious. Sorry guys. 600s, 700s, 800s, and 900s. Okay, and these bars are going to eventually touch each other, but we'll get to that point. Okay, so we're going to start with 300 is up at 4. Okay, so I'm going to draw my bar here for 300. That's 4 units tall. 400s is going to be 8 units tall, so it's really tall up here. Okay, all right, and there my bars are touching, so there we go. 500s, I have 7, just a little bit lower than that. Okay, 600s, if you're an artist, you might like doing this because, you know, you get to kind of sketch a little bit. 700s, there are 4. So back down here at 4 with 700. 800, there's 2. And then 900s, there's only 1. Okay, so just looking at this information here, we can kind of see that, you know, if I'm looking at this curving, you know, and drawing a little curve to it, okay, we can kind of compare. And do you think that looks negatively skewed, symmetric, or positively skewed? Okay, I'm going to say that it's probably more positively skewed. Because most of our data is down in the $300s and $400 range. It didn't. Oh, they're talking about samples of laptops. Okay, so most of the laptop computers that they have available on the market are going to be down in the 300 and 400 range. These are going to be like your MacBooks and the really expensive computers up here. So there's not quite as many of those out on the market. Okay, so positively skewed, which means that the mean, it says describe the center and spread of the data by using either the mean and standard deviation. We're not going to get to standard deviation yet. 5-number summary, we'll do that on the back side here. But I'm going to say here that since it's positively skewed, that the mean or the average is going to be higher than the median number. Okay, all right, so and just to kind of verify this, the median number is the middle number. Okay, so if I have 32 numbers here, the middle number will be between the 16th and 17th number. Okay, my 16th number is 523, my 17th number is 538, and if I add those together and divide by 2, that will give me my median. Okay, 523 plus 538 divided by 2. My median number is 530.5. This is the median. Okay, now to find my mean or find my average, you would have to add all of those numbers together and divide by 32. Luckily for me, I have them all listed right here, and I can just say equals average, average, and I'm going to select all of those numbers. Hit enter. Excel cannot calculate the formula. Why not? Get rid of that. Come on. Equals. Okay, get out of here. Equals AV, average. Let's try this again. There we go. 565. So the mean number, I'm going to write that down over here. I'm over here. Mean number is 565.97, something like that. Okay. So again, that kind of validates the fact that the mean will be up here. This is going to be your mean. And the median will be a little bit lower than that. Okay? All right, and that's what will happen with positively skewed. Your average will be a little bit higher than what your mean is for positively skewed. Okay? All right, let's go to the back side. We're going to do one of these real quick. And this is a box and whisker plot. Okay? So box and whisker plot, the thing that you need for a box and whisker plot, I think we did this at the beginning of the year, because you will need the 5-number summary. And the 5-number summary is your minimum, your maximum, you will need your median, you will need a Q1 and a Q3. Okay, those are the 5 numbers that you will need. Okay, min, max, median, Q1, Q3. Okay, so I'm going to go over here, and I went ahead and typed these numbers in. We're talking about minutes per night that the language arts class spent on homework. Okay, so this is like a Spanish class, or no, language arts. That would just be like English class. How long you spent on your English homework, I guess, each night. Okay, so I went ahead and put those in order. The minimum number is 33. My maximum number is 73. And then I need to figure out what my median number is. It's the middle number, okay? There are 24 numbers in this list, okay? So within that 24, those 24 numbers, I could cross off, cross off, cross off, cross off if I wanted to. But 24, if I separate him into two equal pieces, okay, will be 12 and 12, okay? So think of there's like 12 numbers over here, 12 numbers over here, okay? So list it out 1 through 12, and then these are the numbers 1 through 12, these are the numbers 13 through 24, okay? That's what those will look like. So my middle number will be the 12th and the 13th number, okay? So 12th and 13th number, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 is 53 and 54, okay? So to find my median, I have 53 and 54. I'm going to add those together and divide by 2, or just think about what number is exactly between 53 and 54. It's going to be 53.5, okay? All right, now to find the Q1 is just going to be exactly the middle of this first section, okay? So if there's 12 numbers in the first half of my data, okay? So now I have 12 numbers. Those separate out into 6 and 6, or the numbers 1 through 6 and the numbers 7 through 12, right? So what's the middle number going to be? It's going to be between the 6th and the 7th number, okay? So 1, 2, 3, 4, 5, 6, and 7. So my 6th number and my 7th number are both 46s. And if I average those together, it's just going to be 46, okay? I'm kind of going through this fast just because I think we did this at the beginning of the school year. So my second half of my data is, there's 12 numbers, okay? This is to find the Q3. Okay, if I separate that out, that will be 6 and 6, which is 1 through 6, and 1 through 6 and 7 through 12. So the 6th and 7th number on the back side. Or I can do the 6th and 7th number from the bottom. So I can go 1, 2, 3, 4, 5, 6, and 7. So 60 and 62 are going to be my 6th and 7th number. Okay, so to find the Q3, I'm going to do 60 plus 62 divided by 2, or I can just think what number is exactly between 60 and 62, and that's going to give me 61, okay? All right, let's see if I can erase some of this. Now, we just need to make our box and whisker plot. And to do that, my lowest number is 33, my highest number is 73. Let me go full screen now. Okay, lowest number is 33, highest number is 73. So I'm going to go from like 30 to maybe 80 here. Okay, so I'm going to make like a number line here, and I'm going to go 30 here and 80, and I'm going to try to evenly space these out. So I have 40, that's not going to work, I need to make him smaller. 30, let's say 40, 50, 60, that's better, 70, 80. Okay, so 30, I have 40, 50, 60, 70, and 80. Okay, trying to space those as evenly out, or as even as I can. Okay, and then I just do my box and whiskers. So I'm going to start with minimum and maximum, and I'm going to put 33 as a dot right there. It's just a little to the right of 30, okay? 73 is just going to be a little bit to the right of 70, okay? And those are my two dots on my end, okay? And then these three numbers are going to be the part of my box, okay? So I'm going to start with 46, which is a little bit more than halfway between 40 and 50. 61 is just right over top of the 60 almost, okay? And then 53.5 is almost halfway, right there. Okay, so this is what he will look like, my box and whiskers. Okay, all right, and so that's my box and whisker plot for this language arts class, the amount of minutes that they spend on homework. Okay, So if we look at this, negatively skewed, symmetric, positively skewed, okay? Negatively skewed is going to kind of be that same bell-shaped curve that's looking, you know, on the front side. This one's got a bell-shaped curve that's more even, and this one's kind of on the left side, okay? So negative, symmetric, positively skewed. I would say that even though this bar is a little bit to the right side, I would say that this is pretty symmetric. You might argue with me and say that that does kind of look like it's negatively skewed because the bar is kind of over here a little bit. But I would say that looking at this length in comparison to this length, I would say that those are pretty well about the same. Okay, so I'm going to go with symmetric, right? So just looking at that data, we can make a couple different graphs, and that can kind of help us to determine some things. In the next video, we're going to compare histograms, and then we're going to compare two box and whisker plots. So we'll save that for the next video, okay?